Okay, so welcome to 7-6 surface area, lateral area, and volume of cones. Now, first and foremost, I'd like to discuss what the net of a cone looks like. A cone, first off, has a round base and sides that come to a point. Think of like an ice cream cone, just upside down. Whenever I take this shape and I unfold it to create its net, the base is a circle, and the rest of the cone unfolds to look something like this. So if I'm finding the lateral surface area, I'd be finding the area of this weird shape here. Whereas if I'm finding the total surface area, I'd be finding the area of both of these shapes. So, with that in mind, let's go ahead and go over the formulas for the lateral area, surface area, and volume. The lateral surface area is going to be pi times radius times the slant height. Remember, this L here refers to slant height, just like it did for the pyramids. The formula for the surface area is pi times radius times the slant height. That's going to be the lateral surface area, plus the area of the base. Because my base is a circle, the area of a circle is pi times radius squared. Finally, the area for the volume is the same, actually, as the area of a pyramid's volume. 1/3 area of the base times the height. Just in this case, my area of the base is always going to be pi r squared, because my base is always going to be a circle. With that in mind, let's go ahead and try out example number 1. Example number 1, I've got to find the lateral area, the surface area, and the volume. First things first, let's rewrite those formulas. Lateral area is pi times radius times the slant height. Surface area is the lateral surface area plus the two bases, plus the base. And the volume is 1/3 area of the base times the height. Now, like we discussed, my base is a circle. So if we wanted to, we can replace these big B's with pi r squared, because pi r squared is the formula for a circle, the area of a circle. So looking here, I've got 3 variables. I need my radius, I need my slant height, and I need the height of my cone. The radius is going to be 7. The slant height goes from the tip to the base. This case is going to be 11.4. The height of the cone is unknown as of now, but you'll notice we've just drawn a right triangle. Just like we did with pyramids, whenever I'm missing a piece, we're going to have to use Pythagorean theorem to find what's missing. In this case, I'm going to call this side A, this side B, and this side C. So, A squared plus B squared equals C squared. To move the 7 squared over to the other side, I need to subtract 7 squared. I've got one more step I've got to do. I got to get rid of this square by taking the square root, because square roots are the opposite of squares. Whenever I plug this into Desmos, or whatever calculator you might be using, I end up with 8.997. We're just going to go ahead and call that 9. So, I found that this part of my triangle is 9 meters tall, which is actually the height of my cone. Now I have everything I need to plug in to the formulas. The lateral area is pi times the radius of 7 times the slant height of 11.4, which gets me 250.7 meters squared. Surface area is the same thing, so 250.7 plus pi r squared, which gets me 404.64 meters squared. Finally, volume, 1/3 pi times radius squared times the height, which when I plug in, I get 461.82 meters cubed. And that's it. Find your three variables, and once you find your three variables, plug it into the formula. Let's try out example 2 now. Example 2, again, I need the same formulas from before, so I'll write them out. Lateral area is pi times radius times the slant height. Surface area is pi r slant height plus pi r squared, and volume is 1/3 pi r squared times the height. So just like last time, I need radius, I need slant height, and I need height. Radius is actually missing right now, so we're going to label that X and come back to it in just a minute. The slant height is 27.3, and the total height is 25.2. Once again, notice what we've made here, a right triangle. And what do we have to do to find the missing side of a right triangle? If you were thinking Pythagorean theorem, you were correct. I'm going to have to do Pythagorean theorem here. We'll call this A, B, and C. Remember, the hypotenuse is always C. So whenever I set this up, A squared plus B squared equals C squared. To move the 25.2 over to the other side, I need to subtract 25.2 squared. And these two can't combine yet. If I wanted to combine them into a single number, I'd have to square them first. So instead of combining them into a single number, I'm just going to stack them next to each other just like we did before. And then to get rid of the square, I square root. And what that gets me is 10.5 for my radius. Now that I've got all my three variables, it's as simple as plug and chug. Let the calculator do the work. So there's going to be pi times the radius of 10.5 times the slant height, 27.3, which gets me 900.54 inches squared. Plugging that in for the lateral surface area, I get 900.54. Then I have to add pi times radius squared. And I get 1,246.90 inches squared. Last but not least, 1/3 pi times radius squared times the height of 25.2. That gets me 2,909.42 inches cubed. With that, that's actually the notes for today. Just 2 problems. The main difficulty of today lies with Pythagorean theorem and finding where the triangle is. If you understand what we did here to get this radius, you'll do fine on the practice. If you have any questions, please feel free to leave them down in the comments, email me, or find me in the hall. Otherwise, good luck on your practice.